In this lesson we will solve trig equations, and we've already been doing most of this work when we worked with inverse trig functions. Um, with inverse trig functions you only have one solution. With a trig equation you have infinite solutions. So here when we look at, we already know about the graph of sine. And let's also remember that sine is y over r, cosine is x over r, tangent is y over x. Today what we'll do, we will look at the graph. We can look at the graph of sine, but now we want to find out when sine equals 1/2. So here's the graph of sine, and then we're going to graph the line y equals 1/2. So if that's 1, then there's 1/2. We have a horizontal line. We want to know when does the graph of sine equal the graph of 1/2, y equals 1/2. So we see that they intersect at pi over 6, 5 pi over 6. This continues and it has infinite intersections, so there are infinite solutions. And we can say that it's going to intersect at pi over 6, 5 pi over 6. Over here we're going to add another 2 pi. So if you add 2 pi to this, that's 12 pi over 6, and we get 13 pi over 6. If we add 12 to the 5, we get 17 pi over 6. We can write the solution like this, or we can also do this. Pi over 6 plus 1 revolution n times. Here's the other solution here, plus 2 pi n, where n is an integer, and that's another way to write out all the solutions. When we do the work, we're not going to write it like this. We're just going to use a graph of the angle to find the solutions. All right. Here, we want to isolate the trig function if possible. And here it is possible. We can subtract tangent. Let's subtract tangent. We'll also add radical 3. So here we get tangent is equal to radical 3. And let's make sure that's a fraction. And let's look at the ratio. The definition of tangent is opposite over adjacent. Now, opposite and adjacent, y over x, they can both change signs. So we could have a positive over positive, or we can have a negative over a negative. And this will give us if we look at this, the opposite side is radical 3, the adjacent is 1. We have a 1, 2, radical 3. So we already know that angle. It's a special angle, special triangle. And if we go on the other side with the negatives, we're going to go and here is a way to think about it. It's not correct to say that a distance is negative, but it works. So we're going to say the opposite and the adjacent hypotenuse. So we look at this angle, that's a pi over 3, and so we went there, and we have to go all the way over there. What's that angle going to be? Well, this is pi. If we go here, it's pi, which is 3 pi over 3. So we go one more pi over 3, and we're going to have 4 pi over 3. if we continue around, if we go all the way around and end there, this would be 2 pi, or 6 pi over 3. So I'm going to go around 6 pi over 3, and that'll be 7 pi over 3. Here, if I went around, it would be 6 pi over 3, and then 9 pi over 3, and 10 pi over 3. So we're adding 6 to this to get to 7. We add 6 to this to get to 10. And that pattern continues. Another way to write it is just write the solution here and go plus 2 pi n, and then write this solution. And n is an integer. Pause the video and try that one. Remember, you want to get sine isolated. So we want to move this over. Divide by 2. And we know that sine is opposite over hypotenuse. The opposite is positive. And the hypotenuse is 2. If we don't recognize that this is a special triangle, we can do the Pythagorean theorem, and we would see that. So since it's isosceles right triangle, we know that's pi over 4. And we have, that's x. X equals pi over 4. And then this would be 3 pi over 4. There are infinite solutions, so then we would write it as pi over 4 plus 2 pi n, 3 pi over 4 plus 2 pi n, where n is an integer. Now we have sine squared, so we're still going to isolate sine, but then we'll use square root to cancel the square. Let's subtract 1 and divide by 4. We need to get sine by itself, so now we're going to do the square root. And we're going to have opposite over hypotenuse. The opposite is positive radical 3, and that would give us this. But we also have a negative radical 3. So now we have those 4 angles, and It's a special triangle with a 1 there and a -1 there. So this angle is pi over 3, and this is going to be 2 pi over 3, and then 4 pi over 3 and 5 pi over 3. We could write each of those 4 angles and then add 2 pi in, but these are, this is pi. If we go pi over 3 plus pi, we get to 4 pi over 3. So a shortcut for this would be, instead of 2 pi in, let's just add pi in. And at 2 pi over 3, we're going to add, and we'll add pi in, where n is an integer. So if we started pi over 3, we can add pi, add pi, add pi, and we'll keep hitting these angles. If we started 2 pi over 3, we're going to add pi, add pi, add pi. Pause the video and try that one. Divide by 3 and square root. Make it a fraction, and we know that cotangent is adjacent over opposite. So we can have positive 1 over positive 1. Here are all the options, because we can have positive 1 is this, or this. Negative 1 is this, or this. So that gives us 4 angles where the adjacent is positive, the opposite is positive, and we'll have this. That's a special triangle. We could have the adjacent negative and the opposite negative. We'll have that triangle. Here we have a adjacent is positive and opposite is negative, and that'll put us down there. Here we're going to go left and up. Here we have a special triangle, 45, 45, 90, and we're going to get pi over 4. Again, we can just add pi to it, so it's going to be plus pi in, and that will give us that angle, plus pi, plus pi. Over here we have 3 pi over 4, plus pi in. And in this case, we don't have to stop there. We can just say this. It's pi over 4 plus. Here we're going to add pi over 2, add pi over 2, add pi over 2, add pi over 2. We keep adding pi over 2, so we could just say it's pi over 4 plus pi over 2n, where n is an integer. If you write it like this, it's correct, and then we could also simplify it to that. Here we can't isolate a trig function, so we're going to have to factor. Let's start by subtracting this. Now we see a common factor of cosine. And since these multiply to get 0, then either cosine must be 0 or 2 sine x minus radical 2 must be 0. And now we have two equations, and we can isolate here. This is adjacent over hypotenuse. The adjacent is 0 and the hypotenuse is 1. Well, if the adjacent is 0, we're there, and the hypotenuse, we shouldn't call it a hypotenuse. We should call it the radius. The radius is 1, so we could be there or there. Add radical 2 and divide by 2. And with sine, we're going to have opposite over hypotenuse. The opposite is positive. Hypotenuse. And if you don't recognize this as a special triangle, you could do the Pythagorean theorem and we'll get that. And that's pi over 4. That is 3 pi over 4. And over here we have pi over 2 plus pi plus pi plus pi. So we have all of these are the solutions. And pause the video and try that one. Let's subtract 3 cosine, and we have a common factor of cosine. They multiply to get 0, so cosine is 0. We need an opposite of 3 and a hypotenuse of 1. But that can't happen because the hypotenuse has to be larger. So this gives us no solution. And when cosine equals 0, we have x is 0, r is 1, and we're back like we had on the previous problem. And that'll give us pi over 2 plus pi n. Okay, and we're just going to add this. This just prevents us from having to say plus 2 pi n. We just write down the few solutions that we get in one revolution. So here we're going to have more than 3 expressions. So Let's go ahead and move that over. And when we have 4 terms, you can always try factoring by grouping. And I think it might be a little hard to see how we're factoring, so you can always do it this way. So we're just putting each of these into the boxes, and here we factor out a negative radical 2. Here we can take out 2 cosine, and we'll take out a 2 cosine here, and we'll take out a 1 there. So now we have 2 cosine plus 1, 2 cosine minus radical 2 equals 0. We were able to factor it, so then this equals 0 or that equals 0. Subtract 1, divide by 2, add radical 2, divide by 2. This is adjacent over hypotenuse. Adjacent over hypotenuse. The adjacent, or the x value, is -1. So we're going to go this way, and hypotenuse, special triangle. So we see that here is a radical 3, so this must be a pi over 3, and that means this is 2 pi over 3. That would be 3 pi over 3, and this is 4 pi over 3. On this one, and we don't say plus 2 pi in because it said stop at 2 pi. We don't continue rotating to pick up more solutions, we just have those two. Okay, the adjacent is radical 2, it's positive, so we're on this side. There's the radical 2. The hypotenuse is 2. If we do the Pythagorean theorem, we'll have those, and we can see that it's an isosceles right triangle, or 45-45. So now we get pi over 4. That's pi over 4, 2, 3, 4, 5, 6, 7 pi over 4. And we have these 4 solutions from 0 to 2 pi. And that's it for today.